Hello everyone. We are going to start the new chapter. The new chapter unit is called function transformation. But before we start doing anything with that, we need to review what the definition of function or general functions are. And then once we have that, then we can go ahead and talk about transformation. First, to review definition of function. What is a function? A function is just basically a relation in which basically every unique point, every unique input value or independent variable, that's your x, will give rise or only give back when you plug it into back to an equation of that relation. It will get you back a unique output or y value. That's called dependent. Okay, now I have given you a few examples of functions, a graph of them. Not the equation, just the graph. Some of them, this stuff that you're familiar with. The first two you're familiar with. Actually, the top three you should be familiar with. This is a line, and the test for functionality or function test, the way you test a relation to make sure that's a function or not, is called the vertical line test. That's what that is. And the idea is that whenever you see a graph of a relation, you draw a vertical line, and this is the vertical line right here. I drew a vertical line. And as you move this vertical line, so as you move it left or right, you notice that at any given point is only intersecting the graph at only one point. Okay, at one point. Remember, this vertical line goes up and down forever. So it only applies, it only hits the graph at only one point. And that means for every unique value of input, there is a unique value of output. Okay, and I could do the same thing for all of these functions. All right, so once you draw that vertical line and then you move it left or right, at any given point, you're only going to have, for every value of x, you're going to have one unique value of y. Now, and there are different functions, quadratic functions, polynomial function. That's the blue one right here. That's the polynomial function. It's actually specifically is the cubic function. We're going to deal with that, talk about that. And then the other ones, rational functions. This is a kind of a funky graph, which is a cool graph. Even though it doesn't look like a regular graph that you see continuous, this is called a discontinuous function. And in this case, you still have a function because it passes the vertical line test. It has asymptotes and stuff like that we can talk about as well, because that's one of the units we have to deal with. And then the next one is the exponential function that looks like this purple graph or a blue graph. I'm kind of colorblind here, but you can see. Again, you do the vertical line test and it will happen the same. Square root function is exactly the same as well. So basically these are functions. All right, let's go to Desmos. I'm going to show you a couple of things. So I went to Desmos and created the parabola, a quadratic function that you know of from last year. And I created this vertical line 0y equal to x plus a. That's how you can do this, create a vertical line so that there is a slider attached to that from last grade. So if you don't know how to do that, that's how you do it, by the way, for the drawing, typing the proper equation for vertical line so that it can actually give you a slider. All right, what I want to just show you is that depending on what function I have, the vertical line test will work. So if I click on this, now blue is the vertical line, and look what happens. And it goes left and right, and at any given point I stop it, you notice that that point right here is only the point between, for every values of x, you're going to have one value of y. Simple as that. 1x will give you one unique y. If 1x gives you two different y values, that's not a function. Okay, now let's go to another function. Here we go. Okay, I can't change the color of the vertical line and the horizontal line, but let's go back to 0 again. That's the vertical line, and look what happens again. When I move it to the left or right, doesn't matter which way I move it, it always hits the graph at only one point and one point only, and that means that's a function. Okay, so as this graph right there, okay, as a square root function, same idea. Okay, you can move it back and forth again, right? You can always hit the graph at one point. This is a very special function. Again, it's a square root function. Okay, and the exponential, here it is, same idea. Okay, so on that side you don't have to worry about, but in this one you can see the graph goes up and down forever. And then there is a specific characteristics of these functions, and there are more functions. I just randomly chose few of them. This is the rational function. It is a very special function. Okay, and in this case, let me actually move, just disengage the exponential. Here it is. All right, and if I end up moving again, it just only hits the graph at one point only. All right, there is an asymptote, which we're going to talk about that vertical line between the two, they don't hit the graph. That's just the boundary that the function does not cross. Okay, and these are the examples of functions. Okay, now I want to show you the example of a non-function. Here is the perfect example of a non-function. All right, and in this case, let me zoom in. Okay, in this case, notice that when you do this, when you do the vertical line test, it's very important to see that at any given point, when I do the vertical line test, the vertical line crosses the graph at 2 points. One is in here, okay, that's 1 point right there, and the next point is down here. Okay, when you have a setup like this, this relation is not a function. Okay, and when we go back to our notes, I have a setup here for you that gives you this, and it says that's not a function. Okay, so that is basically how you look at a function versus a relation, and then go from there.